Have you ever heard of cells?
Cell phones?
No, not cell phones, the cells that make us up.
There are two main types of cells, prokaryotes and eukaryotes.
Eukaryotic cells are plant, animal, fungi, and protist cells. Prokaryotes are bacteria and virus cells.
Let's see what people know about them. What do you know about eukaryotic and prokaryotic cells?
Isn't that a band?
Hey, do you know the differences between eukaryotic and prokaryotic cells? Okay, please tell me you know something about eukaryotic and prokaryotic cells.
Oh yeah, eukaryotes have membrane-bound organelles and prokaryotes don't. So, as you can see in this handy-dandy picture, prokaryotes don't have as many organelles as eukaryotes, but more than that, prokaryotes lack the membrane-bound organelles that eukaryotes have. Well, let's go a little further than that. Let's talk about their DNA.
Let's start with what DNA actually is. DNA is found in all living organisms, and DNA is the carrier of genetic information. But does this mean that DNA is the same in eukaryotic and prokaryotic cells?
Even though all living organisms have DNA, that doesn't mean that all cells have exactly the same DNA.
For starters, eukaryotic DNA is usually linear, except in the case of mitochondrial DNA, while prokaryotic DNA is always circular.
Another big difference between prokaryotic DNA and eukaryotic DNA is that eukaryotic DNA needs spacer DNA in order to survive.
Prokaryotes don't have that problem. In the case of chromosomes, eukaryotes usually have 23 pairs of chromosomes. Prokaryotes generally only have one main chromosome with a few copies of that chromosome. On the subject of chromosomes, let's talk about the base pairs that make them up.
In prokaryotic cells, there are about 100,000 to 12 million base pairs, but in eukaryotic DNA, there are over 2 billion base pairs. Lastly, the eukaryotic genome is much longer than the prokaryotic genome because eukaryotic DNA contains substantially more genes than the prokaryotic DNA contains.
Now that we've talked about the differences in prokaryotic and eukaryotic DNA, let's talk about their similarities. For starters, in every type of cell, the DNA strands are anti-parallel. Another similarity between the DNA in these types of cells is that there are always 10 base pairs for every complete turn of the helix. Going back to the base pairs, all DNA molecules have the same 4 nitrogenous bases that make up the base pairs.
These nitrogenous bases are adenine, guanine, thymine, and cytosine.
No matter what type of cell the DNA belongs to, adenine will always bond with thymine, and guanine will always bond with cytosine. Lastly, in every type of cell, the width of an adenine-thymine bond will always equal the width of a guanine-cytosine bond.
Hopefully all this DNA information makes sense, and if it got lost in translation, just blame the RNA. Bye!
Types of cells, prokaryotic and eukaryotic DNA. Oops.
Eukaryotic cells.
No, stop. DNA is found in all living organisms, and DNA is the carrier.
You need to move your puppet.
Let's talk about their DNA. Oh my god. Going back to base pair. Stop. I can't.
Another big difference between prokaryotic DNA and eukaryotic DNA is that eukaryotic more genes than prokaryotic DNA contains.